Hello everyone. So in this video, I will be showing you how to solve a recursive problems, right? So I will be actually dividing this video into three parts. In the first part, it means in this video, we will discuss all the problems that are basic problem that how to approach to some of the basic problem that is easy level problems. In next video, we will solve some easy and medium level problems, and in the third video I will show you the most complex problems and how we can use recursion and how we can solve those questions in very easy way. So by the end of this video, I think you would have some basic knowledge how to solve recursive problems, right? You will get to know how to write the base cases and how to think about that question, that how you should approach to solve that question, right? So I will be giving you very simple thing. So we are going to start with recursion. So I'm not going to discuss about theory of recursion because we will directly jump into the approach to solve any problem. But I will be giving you some basic recursion definition, which is very important to understand, right? So actually, guys, what is recursion? So if we talk about what is recursion, recursion is a process in which a method call itself continuously, right? You have heard this many times that suppose if I have a method fun, let's say function method, right? And some codes are written inside this function. So recursion means that we are calling this function again and again, but actually this definition is incomplete. Yeah, the definition is right, but the definition is incomplete. We need to add one more word to complete this definition, that calling the same function continuously is right, but calling the same function with a smaller value is called recursion. With a smaller value, or we can say subproblems, right? For example, if I am giving you one example of, let's say, factorial number, right? I hope you know what is factorial number. So how we find factorial number, factorial of given number, right? Let's see. Suppose I am giving you a number 5 and I am asking you to find the factorial of this number. So you can easily say here 5 into 4 into 3 into 2 into 1. Whatever the value is, this is going to be our answer. And I think the value will be around 120 or something like that. I am not sure, but let's see. I am giving one example. So 120, let's see. Now the thing is that for finding the factorial of 5, you need 4, right? You need to multiply it with 4. Similarly, you need to multiply it with 3, 2, and 1. What if I am giving you second case? Let's say this is case 1, in which I just asked you to find the factorial of a number. And let's say we have case 2, in which I am asking you to find the factorial of the number. But this time, I have given you something, that is that what is the factorial of 4? And suppose I have given you this, right? So let's say factorial of 4 is 24, right? So if I have given you this thing, and now if I am asking you to find the factorial, then how you are going to do this? It's very simple now. You just need to multiply your 5 with the given value of 4 factorial, that is 24, right? It means if I have given you factorial of 4, then you can easily find the factorial of 5 by multiplying it with the 4 factorial value, right? Similarly, if we want to find the factorial of 4, we need factorial of 3, right? We need to multiply it with factorial of 3. So you can see, for finding the factorial of 5, we need factorial of 4. For finding the factorial of 4, we need factorial of 3. And similarly, for finding the factorial of 3, we need factorial of 2, right? And we need to multiply it with 2 factorial, right? So you can get one logic from this, that every time the same function is calling but with some smaller value, right? So if I'm just writing the algorithm for this, then what will be it? Let's say I have a factorial, just I'm writing the functions, right? Factorial int n, right? Let's write the code. So first you need to write the base case first. right? And what is this base case? Yeah, every time you are calling, actually, why we write actually base case? If you are calling, right, I told you that if our number is n, then we need to call function with value n minus 1, right? And this you will keep it calling, you will keep calling this n minus 2, n minus 3, and so on, right? Now the thing is that calling recursion is okay, but at some point the value will be 1, you can say 1 or 0, something like that. After that you will again call for 1 n minus 1 value, then it will call for the negative value as well. But we don't want to compute for that value, right? For that we need to say, we need to give a base case that you should keep calling the function, but till where you should stop, uh, where you should stop the calling this function, right? So we should actually give the base case, and that is called base case, right? So we need to give that condition. So let's say I am writing the base case. So now the very easy way to think that what should be your base case is find the minimum possible value. Let me write it: minimum possible value of this n, right? This n. Okay. So what should be the minimum possible value, right? I'm just using this word as well. It means you cannot say that minimum is minus negative, right? Because we want to know the minimum possible value. Now in this factorial, we know that we cannot go for the negative number, right? So we need to stop where we can't even find factorial of 0. Can you find the factorial of 0? No, right? It means the minimum value for n is going to be 1. Someone can say you that, yeah, hey, please find the factorial of 1, right? So this can be our base case. So think about the minimum possible value. So this can be your base case, right? So let's write, if your n value is 1, then you need to return, right? You need to return from it here. Return what? Return 1. That's it. Okay. Now you can think this base case in one another way, that is, on which value you should not go and you should not call recursion, and you should return some value, right? This could be your minimum value. So that is called base case, right? So let me write other things. Now, what if n value is not equal to 1? What if it is greater than 1? Then in that case, we know that we are simply going to return n into fact of n minus 1, right? So here you are calling fact n minus 1. It means you are calling for the smaller value. So these are the very basic things. Okay. I'm not saying that this is your approach to solve some problem. Just I am giving one basic idea of recursion. And I think it's enough for you now, right? Why I am saying you that calling recursion is not a complete definition. Calling recursion with some smaller value is called recursion. Now it is complete, right? So I am just proving you that why we need to add that word, right? What is the point if we are calling recursion and we are just passing the same value again and again, right? It is going to call factorial, or it is going to call this function infinite times. So no need of saying that definition. Now let's come to the approach, how to approach a problem. So just I'm going to give you a very simple technique to solve a problem in which you don't even need to think about recursion. Just think that recursion is not recursion. Now think as a person that recursion is your friend. Think recursion as your friend. And this friend is very loyal friend. The friend is very loyal friend, right? Loyal at the same time the friend is very smartest. Very smart friend, right? Now you can think you think a friend is very smart as well as loyal. Now I mean that not handsome. I mean that very intelligent, right? Now let's take one case. Let's take one case. Let's say your mother have given you one work in which you have this room and you need to paint all the four walls of this boundary or room or anything like that, right? So Your mother is giving you the task, right? And you are this, right? This is us. And mother is giving you the task, but with the task giving you something to paint, है ना? It means your mother is giving you what? Your mother is giving you paint brush, right? Similarly, let's say paint and paintbrush only, right? Now, just think this case that you are going to you are going to paint these four walls. But the thing is, you just called your friend. Your friend is very loyal and at the same time very smart, right? So you call your friend and you asked your friend to, bhai, please come help me to complete this work. So, but I just forgot to add one more point that yeah, he is intelligent, like recursion is intelligent, but the thing is, recursion cannot take own decisions. Okay, recursion don't have any idea how to do this. If I will show my friend that you have to do this task by this way, that recursion can do it easily, very easily, right? So just talking about this in this, we have paint and paintbrush, and we need to paint this four walls, right? We have just called our friend and we have asked our friend to paint this wall, but our friend don't have any idea how to paint this wall. So what I am giving my friend instructions that how you should actually handle, right? So I'm just showing that how you should paint a wall. So I will just paint a wall in front of him, and I will show him that how I am using this paint and paintbrush, right? We need to just take paintbrush and we need to put it in the paint, and then we need to apply on the walls, right? So we have told these things to our friend, we have showed him, right? After that our friend got it, and we need to give all the possible values, like what if let's say, let's forget about this, we will cover it later. Okay. So what happened till now, we have painted one wall and we have asked our friend that, hey, I have painted one wall, do you understand how I just completed this work? My friend will understand because he is very intelligent. Now our friend will say, okay, now I'm going to paint other walls now, right? So your friend will paint other walls, but the thing is, you need to pass everything that your mother has provided you, right? Because now you are just giving that remaining task to your friend, so you need to provide all the remaining things, like you have used some point of paint, like 20% paint you have used, but you need to pass remaining 80% of paint so that your friend can do your work, right? Similarly, you are just passing this paint to him. Now your friend will get paint, which is 80% remaining, and then paintbrush. Now your friend will paint all the other walls because he knows that how to paint a wall, right? Because we have already showed him that we have already shown him like how you can paint a wall. So our friend will paint wall for us. So this is exactly very simple example. Now I am going to explain you the approach to solve a recursive problem through one example. I am going to give you one example in of sum of array, right? Sum of array. Now this is the actually one of the problem of Code Studio. Let's see how we are going to solve the problem. Let's see first talk about the problem statement. Now in this statement we can see that we are given an array of length n. You need to find and return the sum of all element of the array. You need to find and return the sum of all element in the array. Now we need to do it recursively. Now you will say, why I will use recursion for this? You can do very easily through iterative method, right? If I am giving you one array, okay, if I am giving you one array and I am asking you to find the sum of this array element, right? You can do it very easily, right? I know that you can do it very easily with the help of for loop. You can simply use a for loop and you can start with the zeroth index, go till I less than n and I plus plus, right? And every time you will keep one some variable and you will keep adding all the elements, right? Sum is equal to sum is equal to sum plus array of I. I know you can do it very easily, right? Now, but we need to solve this question using recursion only. Now you will say that why we are using recursion, and that is actually because this is our very easy problem, and yeah, we can use iterative approach as well. But I just want to give you an idea. After that, when we will solve complex problem, then you will get an idea that how to approach, right? That's why I'm starting with very easy problem. Now let's see, if you need to find the sum of the array using recursion, then this is going to be again very complex for you according to some of the sites and some of the videos, that yeah, you need to think about the base cases, you need to see that how recursion is actually working. But believe me, you don't have to do these things, right? You just have to keep that example in your mind that I have just given you, your friend and you, right? And think your recursion is going to do your work for us. And one more rule that you need to keep in your mind, that never doubt on your friend work, right? Because I already told you our friend is very intelligent. So we cannot, if I'm taking the same example again, so you cannot say that yeah, my friend has done this work good or not, right? Nicely or not, we don't know. Don't never ever question on his work, right? He is going to do your work very perfectly if you have given me the right, if you have given him the right instructions to do the work, right? So similarly, what we are going to do, we are actually working on assumptions. We are going to say, "Ki, hey friend, please do my task for us, and please give me the sum of all the element from 1 to the length of the array. Leave this zero, right? Leave this zero." Now we are assuming that yeah, we are going to do this work, right? We are going to do this work, but the thing is, we don't know what is the sum of remaining array. For that, we will be actually dependent on our friend. We will ask our friend, hey friend, please just give me the sum of all the element. So our friend need everything, right? Our friend need array, and we should give him instruction that from which index you should start, right? So let's start. So in this function, we are given with some array only, right? We are given with some array only. So what we need to first understand that from which index I should start computing the values, right? So for that only you need to what? You need to write something, right? If I say, you need to start with the indexing. So you need to create another function. In this problem only, we are creating another function because the main code is already written. If I will show you, main code is already written, and it this pass part in this part, uh, only input is passed, and we cannot edit this value. See, I'm trying to edit, but I cannot edit the value, right? That's why I'm just creating another function. But actually you can do it very easily. But so let's take online compiler. You'll understand it very easily using online compiler, because I will show you how it is actually working. Let's say I am just giving taking one array, right? Just taking one very simple array. So let's say 1, 4, 5, 8, and again 2, right? Let's say element of size of the array is going to be 5. As I said you that we are going to call function, right? We are going to call function. So we are going to call our recursion. So we are waiting. We are going to call recursion to find the value of this, find the sum of this value, right? So what we are going to do, we are just waiting for the value, and we have called the function which is sum of array, right? So we have this passed sum of array. We have just called a function that we are going to create actually, and in which we need to pass our array that we have just created, and we need to find pass index as well. So we are going to start with the zeroth index, right? From here we will try to find the sum of the all the array element, right? So we are just creating one function. So let's create a function. Let's say public static, and it is going to return int, that is sum, right? That's why the return type is int, and the sum of array, in which I am passing arr and int index. That is going to be actually a start index. Let's say start index, si by start index, right? So what we are trying to do, we are now going to use of recursion. So first of all, base case, right? Base case. What should be our base case? As I said, as I told you, that should be the minimum value, right? Because this should be the minimum value. Now in this function, we have two parameters. Now what should be the base case? Actually this array, every time we are just passing the array, so there will be no change in the array part. There will be only, we are just only changing the start index, that we are just going to increment the start index. And that's why when our start index is equal to, is equal to input dot length, like let's say ki our array length is 0. Let's say our array length is 0. We don't have any array in the input, right? That could be one possible input, right? In that case, what you need to do, you need to call recursion. Seriously, if array is given, array size, given array size is only 5, sorry, a given array size is nothing. You are, I'm just giving you one array, and when you just open that envelope and you saw that you don't have even array in the given envelope, right? I'm just giving you one envelope in which I have said, here I have put all the arrays in that those envelope, right? Now you open your envelope, you found that we don't you don't have anything in the envelope. It means I'm just giving you an array with length 0. In that case, do you need to write code for that? No, right? You no need to find the sum of that. Simply you are going to say, yeah, we are going to start with the 0th index, and if our start index is equal to input dot length, that is 0, right? In our case it is 0 because we are starting from the 0th as our start index. In that case you should return 0 only, right? You will say, yeah, sir, my array length is 0, right? That's it. So this is going to be our base case. Now what we are going to do, we are just going to depend on our friend. Now what we are assuming that our friend will give me right answer. So let's say answer is equal to what? Answer is equal to, we are standing where, let me take one example. We are standing where, we are standing on the 0th index of the array. We are standing on the 0th index of the array. It means we are here, right? Now we have lots of elements, like let's say this is our array, right? 1 4 1 4 5 8 2. Now we don't have to actually wait. We are just on the, we are starting from the 0th index. So this is the place where we are, right? We are actually on this index, 0th index. Now we are just waiting for our recursion. We have called our recursion. Recursion, please do our work for us. So we are going to call recursion, right? So we are saying ki whatever the value, whatever our recursion will do our work for us, right? So whatever the work a recursion will do, what we need to do, since we are starting from the 0th index, what we need to do, we need to, suppose recursion is giving you answer, and recursion is going to give you the answer of this element from 1 to last, right? Recursion is going to give you what, 11, that is 19, sum as 19. Now what you need to do, you just need to add your, where we are standing on the 0th index, so we just need to add this index with the value given by our recursion. So what we are doing, and we are still standing on the 0th index, right? We are standing on the 0th index, that is start index. And actually we have called recursion. So we have called recursion, that is the same function. And what we have passed, what we have given our recursion, we have given our recursion to array, the whole array. But we are saying that here 0th element, please leave the 0th element because we are actually on it. Okay, so I will do that work. You just need to find the remaining element, sum, right? So recursion will leave the 0th element and it will find the sum of the remaining element, right? So recursion is going to do this task for you. So we just need to find, pass si plus 1. Why si plus 1? We are standing on the 0th index. We need to say, yeah, recursion, I am just passing you the whole array, but don't even touch this 0th index, right? That's why I'm saying that this is your start index. So recursion will say, yeah, please tell me what should be my start index. And I am saying, yeah, recursion, si plus 1 is going to be your start index, right? So these are the things, and we are just waiting. Recursion will give me 19 as the answer, and I, what we will do, we will just add the element on which we are standing, that is 1. And we will just, what we will do, we will return answer. We will return answer. That's it. That's it. We have done this work, right? So just I am printing some. If I am printing some here, so what, some value, let's see if it is working or not. Okay, it is connecting to the server. Let me copy the code here. Let me refresh it once. Okay, I don't know why it is not working. Okay, let's open some other online compiler, right? Let's open some other online compiler. This is going to be class name is hello world, in which h and w is capital, right? We no need to change the class name. So the class name was hello and world, and it was not actually public, so we will also remove the public part. Let's run it now. Okay, so we are getting one error. That what is the error? Let me see. Class expected. I think issue with the class actually. Okay, okay. I think what I have done, I've just done everything right. Sum of array, and I have just passed array of array and oh, okay, okay, okay. Sorry, I've just written this. That's why it is not working. Okay, so still we are getting some error. Why it is so? That input dot length, it should be actually array, right? Array, not input. Yeah, so it is giving me the right sum, that is 20, right? It is giving me right answer, that is sum. Now debug is also important. We should know how to find out the error, how to change in your code, right? That is actually very important. So what we have done here, I hope now you can understand now, that we have actually called recursion, but we are just standing on the zeroth index and we have called recursion, and we are just waiting for our friend to complete his work, so that whatever the work he will be completing, like we just need to do some very small work, and we need to say, yeah, this work I have done, this work, right? Yeah, I know that here we are just acting some selfish, but yeah, that is okay for now, right? So this is how recursion actually works. So I'm giving one more example to just understand the concept much better. Let's say if I we need to find the check number in array, right? We have another question in which we need to have a question like check number in array. Let's see the question problem statement. We are given an array of length n, an integer x. You need to find x is present in the array or not. Return true or false, right? So here, what is the problem? Actually, we are given with the array. We are given with the array, right? Let's say array is given. All are the unique elements. We need to say that we are given with the array and one index, not index, that is element, right? Let's suppose one is given here, right? This is actually four. Yeah, one is given. We need to say that do we have this element one in our array, right? So I know that you can still do this very easily using iterative approach, that is by using for loop and everything, but I'm going to tell you how you can do it using recursion. You can even pause the video here and you can think how you should approach. Okay, I hope you have actually tried yourself. It is very good if you are trying to think. Let's see that how it is actually working, right? So what we need to do again, we are going to do the same thing. We are going to call recursion, right? We are going to call recursion. So what we need to do now, we need to stand here. We just need to stand here, and where we are standing, first we need to check that point, that the place where we are standing, is it equal to the element, that is the element which we need to find? No, we are standing on the fifth. We are standing in the zeroth element of the array. That is five element, and the element we need to search is one. So we don't have, right, but we cannot say anything. Now we have called recursion on this part, and we are just we don't know that how actually recursion is working. We don't even have to take care of that. We're just waiting that recursion is going to do this task for us. So if our recursion is going to return us true, it means recursion got the element one in the remaining array. If recursion is giving me false, it means recursion tried to find this element in the remaining array, but we don't have that element in the remaining part. After that, we need to just check. Don't forget to check this the element on which we are standing, right? So you need to just apply this approach. That's it. Okay. I hope if you have just when I asked you to think, if you have thought the same approach, then it is very good for you. Let's see through example. Let's solve this problem using example, right? So we are given with array, and we are given with array and the what and the element that we need to find. So what you need to do again, you need to say the start index, that from which index you are starting, right? You need to say, again I am taking online compiler for this, right? Online compiler. I hope it is now working. I don't think it is still working. Okay, it is still not working, so let's forget about that compiler. Let's work on this only. So let me change the color. Okay, now it is looking good. So what we need to do, we need to start with this, right? So we already have array. Just take one more. Let's say we need to find the element 5. We need to find element 5, right? We just need to say that it is the element is present in the array or not. So we just need to say true or false. That's it. We don't have to return index or anything like that as per the question, right? So what we need to do, we just need to call recursion. Again, we are calling recursion, right? So we are just calling the recursion, and this time let's change the function name, or let's make the function name as search. Okay. So what we are trying to do, we are just passing the array and the element that we need to find, right? That we need to find. So element that we need to search, and again we are starting with the zeroth index because we are going to search from zeroth index, right? So first of all this, right? And after that, whatever the value we will get, we need to store it in boolean answer, let's say, and we need to print that answer, whatever the answer will be. So let's change the function name here as well. It will be search now, and the array and the element that we have passed, so add it here, and the start index will be same. Now talking about the base case, what will be your base case? Okay, I just forgot one more thing, that here we should write boolean, right? Because it is just going to return true or false. So what is happening here? So we are starting with this, right? So if first again the same thing, that again the same condition will be there. What if I am giving you the array with zero length, and if I am asking you to find the element, is that element present in the array or not? So you are going to say, yeah, you have not given me any array and you are asking me to find that array element, then it means we don't have, right? So you are simply going to say return false. Okay, you are simply going to return false, that we don't have that element in our array because the array length is 0, let's say. Okay, so we are just passing the start index and array length is 0. Then in that case, we will do this. Okay, what we need to check other things. I have told you, just before calling recursion, now first make sure that on the index, like on the zeroth index, we are starting with the zeroth index. So on that index, do you have that element present? If we have that element present, that why we need to call recursion? We're simply going to return true, right? So we need to just make one condition, that on the point on which we are standing, on the index on which we are standing, let's check, is it equal to x? If it is equal to x, then in that case we are going to return true. That's it. We are going to return true. Hello. Okay. What if we don't have that element on the index on which we are standing, right? In that case, what you need to do, you need to lie on recursion. You need to depend on recursion. Now, whatever the answer returned by your recursion, either true or false, recursion will give you also a true or false. You need to return that, right? So we are directly returning, and we are just calling recursion here, but we are just passing whatever we have, right? So we are just passing array element and start index. What should be the start index now? Start index should be si plus 1. Why? Because we have already checked in the zeroth index, right? Why we need to again why we need to say recursion, that please check on the zeroth index again? We have checked, right? So we have just calling recursion, and we are saying that yeah, I have checked for the zeroth index, please check for the remaining part of the array. So recursion is going to return you whatever the answer recursion will return you, that will be our final answer, because we know that the element is not present in the zeroth index. If it would have there in the zeroth index, then we would have returned true. But if we are calling recursion, it means it is not in the zeroth index, and whatever the final answer given by our recursion, right, we need to print it. So just run it now. Let's see if it is working. Okay, so I am getting one. Okay, I've just given 2 equals to here, that's why it is giving incorrect answer. mm, Again, what I have done, input, in what I have written input here, why I'm writing input every time? It's array, right? It's array. Variable x, actually x is not there, name is element, right? Okay, so now it is printing true. Sorry for lots of mistakes, actually it happens when you are writing the whole code, right? So what we have done here, we have done one array element, we have taken one element, we have called recursion. Now for the base case, we are checking that if our array size is 0, we need to return. After that, we need to check if array of that start index is equal to that element. We don't even need to call recursion, and we need to return directly true. But if we don't have that element in the zeroth index, then in that case we need to return whatever the answer returned by our recursion. That's it, and we are just printing it, right? So that's a very simple approach to solve any problem of recursion. You just have to think about the principle of mathematical induction. If you're hearing this term first time, then don't worry. This is nothing to do with recursion, but just I'm giving one example. If you have read this principle of mathematical induction in your 11th or 12th class, I don't know, right? So in that now, what we actually do, we just assume, we work on assumptions. We say that if this expression is true for x is equal to 1 value, and if this expression is true for x is equal to 2 value, if this expression is true for x is equal to 3 value, then we can say that this expression is going to true for x is equal to n minus 1 value, right? If we have solved the question of principle of mathematical induction, it means we actually assume. Similarly here, we are just assuming that we are actually, let me try run it once. We are standing on the zeroth index, right? And we are just checking it, that we are standing on the start index is 0, and if we got our element there only, we don't need to search on other part of the array, right? If we don't have that element there, right, if it is not true, if condition is not true, then we need to call recursion, right? And we are assuming recursion is going to do our work for us, right? Now how recursion is actually working, we don't even have to take care of that. But yeah, you should know that how recursion is actually working. Okay. So you can use pen and paper, and you can see all the calls and everything, or I will show you in the next video that how it is working. For now, I hope you got one basic idea of recursion and how you should actually approach to solve one problem, solve a recursive problem, right? So that is going to make your task very easy, and you can solve any problem very easily, right? So thank you guys, thank you. I hope the video is um, good enough for you to understand. And if you guys have any feedback related to the video sound, related to video, related to compiler, related to anything, you can drop in the comment box. I will definitely reply. Take care. Thank you guys for joining.